Let's talk about aldol condensation. So an aldol has an aldehyde, or actually it can also be a ketone, and it has a hydroxyl group, or an alcohol group. So one type of aldol may look like this. There's the ald and there's the ol. So how do we make this? We are going to make it in two different ways actually. You can do it acid catalyzed or you can do a base catalyzed aldol condensation. So I'm going to start with the base. It's a little easier. So we're going to work with acetaldehyde. And we have a base, so we have OH minus. And this OH minus is going to take away one of these protons here. And it's going to push this into a double bond. And these electrons are going to have to get out of the way. So what we end up getting is a set of resonance structures. So we have this one, which is an enolate, and then we have this one, which has a little carbanion. And the one with the carbanion is the one we care about. And it's this structure that is going to combine with another acetaldehyde. So we have another acetaldehyde. And this carbanion is going to attack in here and displace these guys. So this is going to make something, and I'm going to first number these carbons so it's less confusing about what goes where. So that's 1, that's 2, that's 3, and this is 4. So we have number 2 attacking number 3. So if we start over at 1, we have 1, 2, 3, and 4. Take a look at that for a minute, make sure you can kind of see where everything is. Okay, one more step. We made water here in this first step. So in this last step, what we're going to do is regenerate our base catalyst by taking a proton. And so this is going to make our product and OH minus. And there's also a secret second part of this, dehydration. Dehydration can also be done with a base or an acid. So we're going to go through the base catalyzed dehydration here, and then we're going to go through this whole thing with an acid. So in a base catalyzed dehydration, what goes on is you have 2 hydrogens here. I'm going to use a new color for the dehydration. And one of these guys is going to get taken, and these electrons are going to go to this carbon. That's going to make us a carbanion. This is not a smile, it's 2 electrons and a minus sign. And then what can happen is these can go in and make a double bond, and the OH can get kicked out because OH minus is not that bad a leaving group in a basic environment. So then what we get is this. And that's our dehydration product. So now let's try this whole thing with an acid. So if we have an acid, and we have our aldehyde, this acid is going to protonate the aldehyde. That's going to give us a nice set of resonance structures here. So what's happening is we're moving these electrons to the oxygen. And that's going to leave the carbon electron deficient. So what's going to happen now is we're going to bring in that water that we made in the first step. We're going to do an elimination type thing where we take this hydrogen and its electrons come in here and make a double bond. So what we get out of that is this. And this can actually attack another aldehyde. So here's my second aldehyde. And this second aldehyde is going to be protonated because we're in an acidic environment. And the electrons on this oxygen can come back in and make a double bond, kicking this double bond out to act like a nucleophile and attack this carbon. And then this is going to, these electrons are going to come here. I should have written a positive sign because the oxygen has 3 bonds. 3-bond oxygen is positive. Okay, so this is going to make us almost our product. We need to do one more step afterwards, but let's number this so we know where we are in the compound. So we have 1, 2, 3, and 4. And what this makes is this. And in this, it's 1, 2, 3, and 4. So take a minute, orient yourself in these compounds and how they came together. Okay, so the last step is we're going to take a water and deprotonate this. And that'll get us our product. The same thing that we got when we did the acid catalyzed mechanism. So you might be thinking, hey, wait, why did we regenerate 2 H3O pluses? Well, we have 2 aldehydes, right? They both had to get protonated by H3O plus. So we had to make this protonation and this protonation to regenerate them. Okay, so just like we did a base catalyzed elimination or dehydration, we can do an acid catalyzed dehydration. So in this one, if we have an acid, we can make this leaving group easy to leave. It can leave, and we can get a carbocation. And, oops, there are hydrogens here and here. And we can take the water that we made before and attack a hydrogen and make our double bond. And that's what we get, along with regenerating our acid catalyst. We can actually also do aldol condensations with ketones. So if we have acetone, let's do the base catalyzed one. We can take a proton off of here. And basically the same thing's going to happen that we saw before with acetaldehyde. So we can bring in another acetone. And this one can attack. And if we label these 1, 2, 3, 4, 5, 6, not that it matters between 4 and 6, they're symmetrical, but once we make a new thing, it's going to look like this, and this is 5, this is 4 and 6, they can be the other way around. This will have to be 3, 2, and 1. So it's a little weird how it connects, but it's the same basic principle, and then all we have to do is protonate. And we can dehydrate and get a double bond, and remember that by Zaitsev's rule that says that we need the more substituted product when we're doing dehydrations or any elimination where stuff is uneven, because we could have something here or we could have something up here there. The second one is better because more substituted is more stable. So dehydration is going to get us this. Another interesting thing that can happen with an aldol condensation is doing it intramolecularly. So we can actually do it like this. And in this one, if we pick the top ketone to mess with first, then we can have this be like this. Eventually this will turn into a negative charge through the mechanism that we looked at, and it's going to attack in here, and then we'll make a circle. So it will look like that, and then we'll protonate this. And that'll be the product of the Aldol condensation with the circle.